Cool. So good afternoon and welcome to another exciting OpenShift Meetup event. So wherever you're joining from, I'm sure you're going to find the session very interesting and very valuable. My name is Azure Benjamin. I'm a solution architect based in Auckland, and I'm going to be one of your hosts today. And with me, of course, I have the A-team, Joseph and Michael, who are both very familiar faces to you. Joseph and I will be doing the housekeeping today. Joseph, do you want to quickly say hi to everyone?
Hey, kia ora everyone. Good day wherever you're coming from, and good to have you on the OpenShift meetup. Yep.
Cool. All right, so today's agenda, we have a very special speaker from Microsoft who is going to talk to us about Azure Red Hat OpenShift. So we hope by the end of the session, you'll have a good understanding of what Azure Red Hat OpenShift is, what our partnership with Microsoft really means, and how Red Hat OpenShift and Microsoft Azure can help you speed up your container adoption. Then we will show you a demo on Windows containers. So two words that I think most of us in the past will not have thought of using together in the same sentence, but it's going to be an awesome demo, and I'm sure you'll all enjoy it very much. We'll also then have a lightning talk on OpenShift Service Mesh, and talk about why, how, and basically when to use it. Please do note that this session will be recorded and we will post the link later today. So you can watch it, you can share it with your colleagues. And let's make it interactive. So please use the chat box to start discussions, post comments, and also use the question box to ask questions. If there's anything you're not sure about or need more clarification on, please do raise it with us. So we have a special guest from Microsoft today, Clarence Bakirtzidis from Melbourne. So Clarence is an Azure Technical Specialist and is also Microsoft Global Black Belt for Cloud Native Applications. Clarence is also an open source enthusiast. He's also an active contributor to some upstream open source projects. It's awesome to have you with us, Clarence, today. In addition, we have Mr. Smiles, the very familiar face of Michael Kaliza. For those who don't know Mike, Mike is our Red Hat Senior Solution Architect, and he is based in Wellington. Mike is going to give us a lightning talk on OpenShift Service Mesh. He's going to discuss why is Service Mesh important, how and when you can use it in your OpenShift application deployment. He'll give us ideas on what problems Service Mesh solves in this new era of application design and container adoption. So at this stage, let me hand it over to Clarence to kick off his presentation. Clarence, over to you.
You forget to mention, Ash, that I have a surprise today. I'm going to demo a Windows container.
I did briefly mention Windows.
That's supposed to be a surprise.
Mike's demos are always good and exciting. So yeah, I'm looking forward to it. Hope everyone else is.
All right. So am I able to share my screen now?
Yeah, let me just stop sharing. Go ahead,
cool. Okay, let me see. But just let me know when you can see the slides coming up.
Yes, you can see it.
All right, great. Just one little correction on your slide there, Ash. Spelt my surname wrong, but I forgive you. That's happened my whole life, having a tricky surname. All right.
My apologies. I spent the whole morning trying to learn how to pronounce it, and yeah, I did my best.
All good. Yeah. All good. So, yeah, let's kick off because there's a fair bit to cover in a short amount of time, and I was hoping to get a demo in as well. So, yeah, I've been introduced. I'm from the Global Black Belt team covering the Asia region, and I'm based out of Melbourne. So today I was going to give you a bit of an overview of what Azure Red Hat OpenShift, or Arrow, or ARO, however you prefer to pronounce it, is all about. I won't go into too much detail because we have run a few webinars recently covering this topic. So we'll, direct you towards those, but I'll give a brief overview. So hopefully by now you'd know that Microsoft and Red Hat have been working together in close partnership for a number of years now, going back to around 2015. There's a few areas of collaboration. So, for example, bringing the awesome Red Hat Enterprise Linux onto Azure as a supported offering. Also, SQL Server, yes, our flagship database runs very well on RHEL, and also some RHEL offerings for SAP HANA solutions. Now, today we're going to focus on OpenShift, which is the one that's sort of got the box around it there. Now, you can run OpenShift on an IaaS offering, so you're managing it yourself on VMs, but we're going to focus on the managed offering. So just a few things to highlight here. So it's the same OpenShift that you know and trust. It's the same kind of interface, OpenShift 4. But what we've done is we've packaged it up as a managed offering, and this has been jointly engineered by both Microsoft and Red Hat. Comes with a 99.95 availability SLA and a number of various certifications that you can see listed there. Now you have the existing tooling that you can use from Red Hat. In addition to the tooling that you're using already, you can also use some of the Azure offerings, and we'll cover a few of those just to so you have the choice really whether you want to run some of the PaaS offerings on Azure or use the sort of natively integrated offerings within OpenShift itself. And one of the other great things is you have the flexibility, so you can spin up these clusters yourself, you can scale them yourself. It's fully integrated into Azure Billing and into the portal. There's pay-as-you-go, and you can also do reserved instance pricing. So you don't really need someone else to go and provision these things for you. You can go in there and control it yourself. From a support perspective, we work closely together. So if you look at the top, we have a site reliability team, which has both Microsoft and Red Hat engineers on there. So we're monitoring the platform, making sure there's no issues, and also pushing out critical patches onto all the environments. If you run into any issues yourself, you can basically just go to the Azure portal. You don't need to directly contact Red Hat. You go to the Azure portal, raise a support request, and then that will be triaged. And we have integration between both Red Hat and Microsoft support platforms. So there'll be consistency in terms of any notes that have been taken down by the engineers, and we can case exchange those support tickets between our two systems. So it'll be a single experience from a customer perspective. Now, if we take a look at what running OpenShift on Azure looks like, this is what you'd have if you were running on an IaaS platform. There's a lot of components that you would have access to that you'd be sort of maintaining. You might have some additional support from a partner that's helping you run this environment. But at the end of the day, Microsoft's just providing you the underlying infrastructure, and the rest is your responsibility. Now with Arrow, you can see here, it's a lot simplified. And the underlying platform is managed by Microsoft and Red Hat. And you get a single console and an API access or CLI access to manage your cluster, as well as integration through, for example, single sign-on with Azure Active Directory or other identity providers of your choice. From an operational perspective, you get full cluster admin access. So whilst the platform is managed underneath, you have full access to the cluster to install your own operators, custom resource definitions, manage RBAC, and so forth. From an identity perspective, you can use any of the existing identity providers that OpenShift supports. If you're using Azure, you'll probably be using Azure Active Directory, but you can also add additional identity providers potentially for supporting partners or vendors that you're working with. They might have their own identity provider that you want to integrate. Now, from a networking perspective, everything runs on Azure Virtual Networks. So you can peer your Arrow cluster with other services that are running in other VNets. So for example, you might be running Azure VMs or other services in those VNets, and you can basically address those through peering, as well as accessing on-premise networks through ExpressRoute or VPN gateways. And when the cluster is installed, if you're using a region that supports availability zones, so for example, the nearest one for New Zealand would be Sydney. So Australia East has availability zones now. So if you create an Arrow cluster there, you'll have your VMs, both the master and worker VMs, distributed across the 3 availability zones, as you can see in the diagram. And you can create additional machine sets as well as machine scale sets, and that will basically span those availability zones as well. So the creation experience is very simple. There is a prerequisite before you run the CLI command to create the cluster, which is creating a VNet. It's pretty straightforward and well documented. So you create a VNet, 2 subnets, one for the worker nodes and one for the master node and one for the worker nodes. And then essentially once you've got the VNet, you can run this command with some parameters to create your cluster. It takes about 30 minutes to fully spin up the cluster, and then you can access it through the default user, which is a kubeadmin user. Just one more thing on that. So we do have ARM template support. We're working on documenting that. And in the future, you can expect other support. For example, Terraform is another provider that we commonly support for Azure infrastructure. From a monitoring perspective, by default, you get Prometheus and Grafana out of the box when you create the cluster. You can also supplement that with Azure Monitor. Now, this is currently in preview, the integration with Arrow, but what it will give you is essentially all your metrics and container logs will be sent to Azure Monitor external from the cluster. So you might use that, for example, for longer term storage of your metrics, or potentially if you're using other Azure services, you might want a unified dashboard for multiple services. But just a bit more on Azure Monitor. As I said, if you're using other services, you can get visibility of all of the different services, for example, VMs, PaaS services, and any other types of services that you're running. They all show up at a glance, including your Arrow cluster. And then you can drill down into those services for more details. You can also take advantage of alerting and incident management. So you can set up workflows where if there's a particular alert, whether it's a metric or log-based alert, that can actually trigger a workflow through something like Logic Apps, which is a workflow engine, or Azure Functions. And we do have some connectors if you need to, for example, raise a ticket in a third-party tool like ServiceNow, for example, or Jira. You can actually have that connectivity to raise the ticket. Another example is potentially using a system like Trello to send out, for example, SMSs. Now, if you're using Prometheus, we can also have Azure Monitor scrape Prometheus endpoints. So whilst you can go into OpenShift and look at the Grafana dashboard and the Prometheus metrics there, you might want to also be scraping those into Azure Monitor, as I said, for longer term storage. So you could scrape from, for example, services directly, or from any exporters that you install, or potentially if you're using like a push gateway for, cron jobs and so forth, you can have that also being scraped. And once you've got all the logs and metrics in Azure Monitor, you can use our advanced querying language, which is called Custo or KQL. Takes a bit of time to learn it, but once you understand how it works, quite powerful to create aggregations. You can plot charts and so forth, as well as look at tabular results. We'll have a look at this a bit later. There's also App Insights. Essentially, this is a application monitoring So you can get performance metrics, tracing and so forth. You do need to instrument your services for this to be connected. Any other Azure services that you use are automatically connected. So you essentially can create like an application map and drill down into specific requests. You can do some of these things already within OpenShift. For example, if you're using something like OpenShift Service Mesh, you can get similar sorts of telemetry through the service mesh and through the Jaeger distributed tracing. So here we can see the application map. So once you start collecting the telemetry and you've instrumented your services, you can start to get visibility of how your services are communicating, and then you can drill down into specific requests and also view exceptions. From a storage perspective, cover a few things here. So you get the OpenShift container registry, which is built in. That uses Azure Blob Storage for persistence. You can also use Azure Container Registry or the Red Hat Quay registry if you want more of a sort of enterprise, centralized, and potentially geo-distributed registry. So we'll look at ACR a bit in the demo. The two main storage classes that you have available to you on Azure, Azure Disk and Azure Files. So the default is Azure Disk, which is essentially read-write once. But if you need multiple pods to be reading and writing from the same storage, then you can look at adding Azure Files as a storage class, which is very straightforward to do. Now, of course, you've also got Red Hat's container storage, which is based on Ceph as well. Here I'm just highlighting the native Azure options. Now with persistent volumes based on Azure Files, we support SMB as the protocol. We do have NFS protocol for that as well in preview. So some customers want to be using NFS instead of SMB. SMB does work across Linux, Windows and Mac. With Azure Files, you can also have on-premise shares being synced to that cloud storage as well. So you can have essentially your cluster writing to these shares and also on-prem syncing happening as well. And we do have options for increasing the available IOPS with the premium storage option if you need higher IOPS for your persistence needs. But we typically wouldn't recommend running, say, like a database on Azure Files. We'd recommend using Azure Disk just because of the latency associated with a network file share. For backup, the current approach is to use a third-party backup tool. So, for example, Valero, which is an open source tool that you can take snapshots of any persistent volumes. For example, your Azure disks, as well as the etcd state that's stored inside of the cluster. So all your objects and all your CRDs and everything like that, they're all stored in etcd. So you can use this tool to back those up to blob storage and restore them at a later date. Now in the future, you can expect that would be more of an integrated solution for backup, but today this is a recommended approach. From a security perspective, there's a lot of obviously OpenShift itself is very secure by default. However, when you're exposing services to the public, you probably want to look at some additional ways to secure that network traffic. So there's some of these options that you can look at. For example, putting a WAF in front of your cluster to protect against some of the OWASP top 10 attacks like SQL injection, cross-site scripting, and so forth, as well as putting geo filters to allow or block traffic from certain regions. So with the WAF, there's two options. You can use App Gateway. So I've had some customers looking at putting this in front of their cluster. Now, App Gateway is regional, so it doesn't do cross-region, but it can actually front a number of different services within the same region. So you potentially could have Arrow plus other workloads that this is fronting. You can enable the WAF feature, and it's layer 7 load balancing. So you can do path-based routing, you can set up your own certificates in there, which can integrate with Key Vault as well to store your certificates securely. Now, front door is another option, which is this one can actually span multiple regions. It also has additional features, including the WAF, but also CDN, and also acceleration of application content. So this could be used where you want to do geo failovers, for example, if there was an issue in a particular region and you want to fail over to another region, or you're serving global traffic, then you can use front door to route customers to the nearest point of presence. And when it comes to managing TLS certificates, you could of course have these statically provisioned, and then you need to think about where you store those. So one option is you can put them into Key Vault. The Key Vault can store certificates that you've already purchased from a CA, or you can actually have it integrate with a number of CAs that we support to auto-generate and rotate your certificates. This is all programmatic through APIs, and once you've got your certificate there's a number of ways you can get that into your cluster. So for example, if you're exposing your OpenShift routes, you could potentially just integrate the certificates through Ansible or through some bash script. But if you want in-cluster integration, you can potentially look at our CSI secret store driver, which can directly integrate with Key Vault and pull those certificates from Key Vault and store them in a Kubernetes secret ready to be used for your router. Now, if you want to use another method, so if you're not using Key Vault, potentially you want to use free certificates from, say, Let's Encrypt, you can also install the certificate manager via a Helm chart or operator into your cluster, and then this will manage the certificates and rotation for you. From a secrets management perspective, by default, the secrets are not encrypted at rest. You can turn that on optionally in the Arrow cluster. And the other option is you can store your secrets in Key Vault. So much like the certificates that we talked about, you can also store your secrets in Key Vault. And through that same secret store CSI driver that you can use, you can pull your secrets from Key Vault and have those attached to your pods at runtime. Now, just a bit more on security. If you're using container registry, the Azure Container Registry, we also have image scanning available. The Quay registry also has this with Claire. This is the Azure's alternative option, where if you're using ACR, you can essentially have Qualys scan your images for vulnerabilities. Now, there's also integration with Azure Sentinel. So if you're using Azure AD for sign-in and you want to look for anomalies or potential threats, you can have Sentinel ingest your sign-in logs, audit logs. So see who's changing permissions within Azure AD, potentially assigning different roles to users, and also with Azure DevOps if you're using that for your pipelines. And then this is all ingested into Sentinel to highlight any potential security risks. And lastly, pipelines. Now there's integrated pipelines now with Tekton in OpenShift 4. There's also Azure Pipelines, GitHub Actions, and other CI/CD tools you can use external to the cluster. And what's popular these days is using what's called a GitOps approach, where you essentially manage all your configuration in a Git repository and have an agent such as Flux or Argo CD pull those changes into the cluster and apply them. So this can be more secure where you don't need direct access to the cluster. It's all managed through commits to version control. Now, if you're using Azure PaaS services, there's a number of those you can use for persistence. But also you can store, you can use persistence within the cluster. There's a bit more work on your part. It's often recommended to keep your services as stateless as possible. And here you could leverage the PaaS services from the Azure ecosystem. So some of them are listed here. There are various databases like MySQL, Postgres, as well as caches like Redis and also Cosmos DB. Now, when you access these PaaS services, they've typically got a public endpoint. Many customers want to secure their endpoint, and we have the availability to do that through either service or private endpoints, where you can lock down access to those public services such that you can only route traffic from your virtual network. Now, before we get into the demo, I just wanted to talk about the service operator, because the demo is going to be focused on this. As you know, in OpenShift, a lot of the administration is handled by operators. That eventually takes a lot of the work away from, managing the day one and day two operations of your cluster. So following that pattern, what we've done is we've been working on an operator that makes it easy to provision services in Azure, but using the YAML or Kubernetes manifest that you're familiar with in OpenShift. I'll show you a demo of this. So currently we support a few different services. I'll just skip ahead. So here's some of the services that we support. So it's not the full range of Azure services, but you can provision various databases and storage backends, and we'll see this in the demo. So this is a demo I'm going to show you. It's a microservices application that's using Cosmos DB. And we'll see that Cosmos DB, as well as App Insights, will be provisioned through this service operator. So let's jump over to the demo now. Okay. So what I want to show you is, let me find the right window. Here we go. So this is the demo. I've actually modified an existing project, which was just a Kubernetes one. I've adapted it to work for Arrow. So you can have a look at this yourself in your own time. As a starting point, here's my Arrow cluster, and I've got a project set up. It's an empty project called Arrow Demo, so there's nothing in here, as you can see. And on the Azure side, I've got a resource group also called Arrow Demo, and all I have in there is container registry, which is storing the images for the demo. Now, currently you can't provision container registry through the Azure Service Operator, so I've pre-provisioned that. And you'll see that there's a number of images in there already for our app, so the 5 images that our application needs. So what we'll do is we'll kick off the demo, and I'll walk you through what's happening. So I've just got a short cut, so demo up. Now this is going to create a number of resources for us. So while that's running, we quickly jump into the script for the demo. So if you look at up, there's a few things that are happening. So first of all, because we're using the Azure Container Registry, I'm populating a pull secret so that we have permission to pull from that registry. Then I'm going to deploy some Azure resources using the Azure Service Operator. I've already installed that in my cluster. And then lastly, we're deploying the app. So let's have a quick look at that. So the pull secret, as you can see, I'm retrieving some information from Container Registry and creating the secret and attaching it to this service account. Now, by doing this, it means that whenever we want to deploy something that uses a private image, we don't need to provide the pull secret. It's there in the default service account. Now, to deploy the app, I'm using Helm charts. So there's 5 Helm charts for our app. And then I'm exposing a TLS endpoint for the front end of the app. And then lastly, the services. This is the interesting part. I'm deploying App Insights and also Cosmos DB, but not through using ARM or Terraform or Ansible. I'm actually using just normal Kubernetes or OpenShift YAML. So here, for example, the operator makes some new CRDs available. So here, I'll just zoom in a bit. You can see I'm creating a Cosmos DB. I want it to support the MongoDB API because my app expects MongoDB. The region, the resource group, and then I'm just specifying additional information. If I wanted to, I could set up, firewall access and so forth. And for App Insights, it's pretty straightforward. It's just, here's the App Insights I want to create and the type of app I want to support. So while that's happening, as you can see, the script's finished running. Now what we should see is if I'd say OC get App Insights, you'll see there's actually an object called of type app insights provisioned. Now, if I look at Cosmos DB, let's see, is that there yet? Cosmos DB. Right, so Cosmos DB is still provisioning. So if we jump into the portal and I refresh here, so you'll see our App Insights resources created, and Cosmos DB is currently still provisioning. So that will take a couple more minutes to be ready. So you can see here, I didn't need to know anything about Azure, I just created those resources, and the service operator took care of provisioning these resources for me. Now back here, we can see I've got my 5 microservices deployed. So once our database is up and running, we should be able to see what this app looks like. I'm just going to run, I've got a little status shortcut. So it's just checking our clusters there, our registries there, and now it's going to check all the services and all the components that have been deployed. So you'll notice this data API, which is the one that talks to the Cosmos DB, it's not ready yet because it's still waiting for Cosmos DB to be provisioned. And the way that it actually connects to Cosmos DB is via a secret. So our operator is going to create a secret once the resource is created. I'll show you what those secrets look like. So for example, if I type, just one moment, if I type secrets, at the moment we're only getting one secret, which is the instrumentation ID for App Insights. Once Cosmos DB is ready, there'll be a secret available for Cosmos DB as well. So we'll come back to that in a moment. What I'll do is I'll just show you a bit more about how the operator works while we're waiting for Cosmos DB to be provisioned. So the way the service operator works is you install it. It's actually available via the operator hub, as you can see back here. Currently, I ran into an issue installing it through the official operator, so I've installed it via the Helm chart, and that's working. Now, with what you need to do is create an identity, so a service principal, which grants access to either a subscription or a resource group. Now, if you want to have more fine-grained security, you could provision an operator into a namespace with a service principal scope to a particular resource group, such that essentially don't have access to the whole subscription. So when you want to provision a resource, you create one of these manifests, for example, Cosmos DB. The service operator will detect that, and then it will use its service principal to authenticate with Azure AD, and then it will talk to the the Azure Resource Manager to provision the resource. Now, when that resource is provisioned, it will then create a secret. Now, you have the option to also store the secret in Key Vault if you don't want to have that stored directly in a Kubernetes secret. So I haven't turned that option on. It's going to be stored as a Kubernetes secret. And then lastly, which you can see in step 9, when that resource is available and the secret has been created, then our application that's using that resource can proceed. So here's an example with Postgres. You can see there's a number of options. You can specify the size of the database, the version, and so forth. So it's very straightforward to work with these resources. Okay, let's see how our database is going. So Cosmos, OC, get Cosmos. Yeah, it's successfully provisioned. Great. So if I run that secrets command, you'll now see there's a connection string, so MongoDB, and don't worry, after this demo, I'm going to delete the database so that secret will be gone. So now our application can now use that secret. And I'll show you in the portal. If I refresh this, we'll also see our Cosmos DB is now up and running. Okay, so how do we access our application? Let's click on our URL, and we should see our service tracker application up and running. Right, so the way this works is there's a number of third-party APIs that we call for fetching information like earthquakes, flights, and weather, and we cache those into Cosmos DB. And then next time when you use the app, you don't need to make those external calls, but if you want fresh data, you manually click on these buttons to fetch the data again. So I'm just going to run through that once. And now if I go to flights, you'll see that there's a number of flights, earthquakes. Now, I don't know if this is real data, but there's earthquakes and the weather. You can see it's North America centric and using Fahrenheit. Right. So that's the application. Now I know we've probably only got a few minutes left, so I'll just quickly show you one more thing. There's a few more things I wanted to show you, but just due to time restrictions, I'll wrap up in a few minutes. I just want to quickly show you. So we've got application insights. Now the application itself has some instrumentation. So for example, we can kind of see that, it's calling a number of different services. If we focus, for example, on the data API, so I'm getting a bit of latency here, but essentially you can get the application map and drill down into the specific requests. I'll skip that one for now, and I'll just show you one other thing, which is the Azure Monitor integration. So this is at the cluster level. So you can see here my OpenShift cluster is being monitored, so we can kind of get high-level information about the cluster. I'm just going to show you one more thing. So the data API. Now at the moment, this integration is still in preview, so you can expect to see more features in the future. At the moment, it's a bit limited, but I just want to show that we can get access to the container logs. And then, for example, we could, I'm just going to delete this fairly complicated query to not have the date time in there. I'll just run one query before we wrap up. Okay, so I'm going to show in the last 30 minutes. So let's say, for example, I want to see, let's say, all the saves that are happening. So when we're saving that cached data back to the database, so I'm filtering by those, and then what I want to do is render a chart, for example, so we can see, you could see I click save twice on flights, so flights has been saved more often. Now you can do time series charts. I just don't have time to run through that because I want to allow Mike some time to run his demo, but you can do some sophisticated querying and do even alerts and so forth through this interface. So I'll wrap up there. I actually did have quite a lot more, but just the time, because of the time constraints, I'll wrap up and make sure that there's enough time to cover the other bits and pieces. So I'll stop sharing and hand over to Mike. Sorry, I went probably a bit over, Mike.
Yeah, it's okay, man. Mine is very short anyway. There are some questions, by the way, that was asked by Simon and Byron, and I tried to answer some of the questions, but most of it are related to Arrow, really.
Okay, I'll have a look at that while you're doing your demo.
Yeah. Cool. So how can I share my screen here? Perfect. Okay. Right. Can you guys see my screen now?
Yes, Mike.
Yes,
Yeah,
Mike.
okay. Cool. So what I'm going to do actually is to show you OpenShift 4.6 Windows container. As you can see, the version here is nightly build, so don't do this at home. So this is basically a testing that I did last night. And it's using this 4.6 stable update, but still nightly build. So we talk about Windows containers. I did deploy this in what do you call this AWS because I wasn't able to request for an Azure access from Clarence, but it's all good. Windows container on Arrow will be supported, I think, early next year. So what I'm just going to do, I'm not going to deploy the worker node. To deploy the worker node, the Windows worker node, you just need to use this Windows machine config bootstrapper. So the idea is you deploy your OpenShift cluster, and once your cluster is deployed, you can add a Windows worker node. Cool. So currently, I'm going to use, I'm thinking of using the command line, but let me just use the UI for now. So this is my worker node right now here. So, sorry, my nodes. I have 3 masters and I have 3 worker node. This worker node here is basically a Windows worker node. And if I drill deeper into the machines, these are the running machines. So if you notice, it's span across the Southeast Asia, what do you call this, availability zone. And if I look at my machine sets, I basically have a machine sets here of 4 worker nodes, which basically I don't have a running worker node on the 4 machine sets. Okay, so as well as my autoscaler, I created an autoscaler here as well because I'm going to attempt to demo an automated scaling using using Windows worker node. Okay, cool. So before going to the what do you call this, the application demo, let me try to auto scale. Actually, what I'm going to do is can you guys see my command line right now?
Probably make it bigger, Mike. Yeah.
Okay, let me. How about that?
That's better.
Okay, cool. So as you can see, I have here a machine sets for Windows worker node. Okay, so to investigate further, what is this worker node has, or the what you call this, the machine sets, is basically, if I describe that, it gives me an information about the that specific worker node that I am working now. So currently it has a 16 vCPU, and I have an autoscaler here because that's what I'm going to do. And let's try to autoscale this. But before that, I want to investigate whether my machine API actually has the right declaration. So, and I can see that I have it running here. So let me now scale this up, scale this replica to 2. I am doing this because it will take at least 10 minutes to finish. So as you can see, it's scaled now to 2. If I'm going to my machines, it currently is triggering a provision of Windows machine. And later on, when it's done, we will see that as a worker node added to the what you call this OpenShift cluster. But right now, of course, you cannot see that worker node yet because it's still building. And you can see the Windows worker node that I have right now is the original worker node that I've showed. Cool. Now, what I'm going to do next is I'm going to deploy a simple application. All right. So let me do that right now. So OC new project. Now I'm going to deploy an application, an HTTP application from that will run a Windows application that will run on OpenShift, really. I mean on what do you call this? A Windows worker node. Okay, also new project, a demo. Let me just do that, and that will create a new project called a demo. Cool. Now, let me then deploy an application. So let me deploy an application. What is that? Of course, I have a remnant of -n here because I copy and paste. And if I go to the A demo project, you can see that there will be a workload or running Windows Server there. Because I already have the image, of course, it will just go to create a container. Now, if I do OC describe, the name of that, Win Web Server, what's it? OC get files. Also describe. It's creating a container right now. It will take at least 45 seconds, I believe. Okay, it's not yet. Also describe pod, of course. So as you can see here, when I describe the pod, it's actually getting an image from MCR repository that's called server core. And once it's done, OC get pods. So container creating. What I want to do after that is I'm going to what do you call this? I'm going to expose the web server that is creating. So I don't know why it takes a little bit of time right now. But when I did the demo, when I did the testing, it works well. Let me see. Yeah, it's still pulling an image from time to time. It takes a little bit of time. I didn't expect to take it longer, to be really frank, because it's a small workload. It's still creating a what do you call this? Creating a container. We'll come back to that. We'll go back to the machine autoscaler. It will take a little bit of time, so it's still creating, and I guess that will finish. I think this one will finish in 10 minutes as well. So as you can see, the nodes is not there yet, and it's still provisioning. And let me just go get pods. Still creating. I don't know what happened, but usually this will take a little, a very short time to deploy a small application. I guess because it's not GA yet, that's why we are getting a problem like this. I'll come back to that. The next thing that I actually want to talk to you guys is service mesh. Right? So, and let me actually do this presentation. The reason why I want to talk about service mesh on this lightning talk is because I really believe that when the deployment of OpenShift application grows bigger, it will be more difficult operationally to manage this application. And when I say big, we're talking about maybe 5,000 services on top of a cluster. So the question that I want to answer here is why service mesh is important for feature for microservices deployment, and what does Istio and OpenShift Service Mesh gives you, and what problem it solves in this new era of application design. Well, for me, Service Mesh solves a real problem at the highly elastic and fast-moving containerized application and deployment, as well as on the spectrum of the architecture side, that will only grow in importance as the end footprint increase in the enterprise. As organization move to build application more and more on a cloud native approach and microservices, they are going to be quickly faced on issues and challenges on managing the complex interaction between instances and of course, the highly distributed microservice environments. And on top of that, of course, security is going to be a biggest concern as well, right? So managing this complex environment becomes a challenge, not only for the DevOps team, but also for security, as well as the overall enterprise stance on whether to continue doing this distributed decoupled application deployment or just basically move to the next phase of other approach or other ways of deploying an application, right? So often they also need to add configuration as well, not only on the microservices, but also for the backend, right? To manage this logic as well as to create the more application, the more routes that you need to maintain, the more storage that you need to maintain, the complex the security will be. So to add on that, handling service migration as well, like when you do A/B deployment or canary deployment, it introduces additional dynamic components, specifically on routing, in turns adding more logic to go into the application code, really. And this is adding to the complexity and dependency issue to the code base, that basically taking more resource from the developer's precious time. So how do you solve this? So in my current opinion and in my understanding, Service Mesh actually solve this. This feature brings behavioral insights and operational control, because once you are inside the mesh, or your application is inside the mesh, you have full control on service communication as well as traffic. And of course, in turn, you will have more control as well on security. It provides really consistent framework for connecting and securing and monitoring the containerized microservices application that you are running on Kubernetes cluster, in this regard of OpenShift. And I guess that's my take on why OpenShift is important to be considered in the future. Right now, if you're dealing on a small cluster, don't worry about it. Maybe you can count the services in your hands, or maybe it's just hundreds. It's not really complex. But if it reaches to 1,000, that's where the challenge is, because of because of managing this number of applications that is that you want to have visibility and insights every time, so that you can get a peace of mind when when managing this or deploying application to your Kubernetes cluster. That's it, and that's my That's my lightning talk. And now we see that the Windows server has now 2 machines, and if we notice, this worker node is now 4, and 2 of that is Windows, and that's how I help to scale. And if I go to the pods in my it's, I don't know why it fall back, but I was hoping it should work perfectly, but sorry to disappoint you guys.
We need to call out the demo gods, Michael.
Yeah, at least one of the demo works, and I can show the scale up. But this application, when I test this last night and this morning, it works. But yeah, I'll troubleshoot it, and I'll find out what's wrong. Thanks. I'll stop sharing.
Thanks. Very much appreciate it. I think at the top of the hour. Thanks, guys, for joining today. And thank you, Clarence and Mike, for your presentation and demo. I thought it was,
All good.
that was
No worries. It was challenging
really
to fit it into the time.
Exactly.
Oh, yeah, no worries. I think we managed to squeeze everything in.
Yeah.
If I have time to troubleshoot this, I'll troubleshoot this.
Absolutely. We'll keep you guys posted. If Mike, we can always post on the Meetup page. So just a quick reminder that the link will be available later today, so you can watch it and you can share it with your colleagues. We also have some stickers and caps available. So if you want one of those, Joseph is on the screen and is wearing one. Please do reach out to one of us via the Meetup message and messaging, and we will either post it to you or Joseph can meet you in Wellington CBD.
And
Yep, stickers as well. There you go. Awesome. Might have to send one to Clarence.
Yeah,
no,
thanks by the way.
And all the questions were answered, I believe.
Mm-hmm.
Yep, okay. Definitely. Yeah. So Mike and Clarence and Joseph answered a few of those as well. So we appreciate that.
And don't forget to join us next month for the hybrid serverless using Quarkus. So yep. Thanks everyone.
Yeah, I'll stop this recording and I need to jump to another meeting. See you guys.
Thanks everyone. Bye-bye.
Thanks, Clarence.